This is Dr. Kumar, Associate Professor, Department of EEE, SNS College of Technology. This is the video series for the unit Operational Amplifier and Timer IC, where we are discussing about ADC techniques. Let we see a digital ramp. Let we see a digital ramp. The another name for digital ramp techniques is a dual slope. This dual slope. ADC is nothing but analog to digital conversion techniques, which is under operational amplifier and timer IC in unit number 5. As the left hand side is the analog signal which is changing in nature, which is given to an ADC unit, analog to digital converter. Hence the output is a square pulse, is a digital in nature. 0 1 0 1 is goes on. Whereas for this principle, for this analog to digital conversion, we need certain very important parts. For this a basic digital ramp analog to digital converter, basically it needs one a clock pulse generator, and this clock pulse generator is given to a digital counter, and this digital counter is given to a comparator, where a digital counter is given to a comparator, where the analog signals is compared with this signal, and the output is matched, now let we consider a sample signal which is shown here. Now let me consider a sample signal. The green color box represents a sinusoidal analog input, where the sample point is mentioned as Vs. For this sample signal, we have for finding the sample signal, first we have to give a pulse, a number of pulse, and the number of pulse is to be counted, with the help of a digital counter. And suppose if the number of pulse given is, let me assume it is some seven pulses. Therefore, the 7 pulses is counted with the help of a digital counter. It will count from 0, 0, 0, 000 to 1, 1, 1, 7. From 7. Therefore, let me consider that if the 7 pulse is given and the counter reaches 7 in digital, and this digital value is converted into analog, such that this analog 7 is compared with the sample point. If the sample point is below this comparison, then again another pulse is given. Or if the sample point is above this comparison, then we have to stop the number of pulses, and we assumed that the sample values is in between 7 and 8. See here the circuit diagram for a digital ADC, where AND gate is given in the left top, in the right top. Here the clock pulse is given. The clock pulse is given as the input to the AND gate, where the number of clock pulses is counted with the help of a counter. See here, a clock pulse is given as an input. Then this clock pulse is counted by the counter, and the counter output is given to a digital to analog converter, where it is converted into again analog, and the sample point and this analog signal is compared with the help of a operational amplifier comparator, which is shown the center in the center. Right. The counter counts the number of pulses, and this sample number of pulses, and this value is given to digital to analog converter. Let me assume it is 7 or 8. Yes. If the values reaches the sample point, it may be 7 or 8 pulses, then the comparator compares and gives that the sample point is greater than the given analog value, or the sample point is lesser than the given analog value. such that the comparator decides to stop the number of counts. Stop the number of counts. For our example, it is suppose if it is 7 pulse, then the comparator stops at either 7 or 8, such that our sample signal Vs is in between 7 or 8. In between 7 or 8. Hope you understand this digital ramp ADC, and thank you for patient listening. Digital ramp ADC.